Computer, begin entry. Evolutionary Files Bestiary 1. Codename Dragon 2. In my previous dragon analysis, I examined the wyvern, a type of dragon I argued was the most biologically plausible of the flying variants. I argued this based on its anatomy: 2 wings and 2 legs, a configuration similar to pterosaurs and birds, which are both proven flyers. There's another class of dragons that are often overlooked: serpentine dragons. These long, snake-like dragons, like the Chinese long or European worm, are typically wingless. Because of this, most people assume they couldn't possibly fly. But is that true? Could we engineer a flying, wingless dragon? Serpentine dragons are often shown slithering through forests and oceans, or even the skies. In particular, Asian dragons are frequently depicted flying among clouds, summoning rain and twisting through the air. While this seems magical, a biological explanation for this wingless flight may lie in an unlikely place: fish. In some Chinese legends, dragons were once koi fish that slowly developed into dragons as they swam up the Yellow River and passed the enchanted gates. Perhaps they were onto something. Fish, especially bony fish, have an organ called a swim bladder. This gas-filled sac helps regulate the fish's buoyancy underwater. To rise, fish fill the bladder with low-density gas. To sink, they release it. This lets them hover or float at specific depths without needing to expend energy swimming to keep themselves at that depth. What if a similar mechanism allowed a creature to swim not through water, but through air? What if an animal could fill itself with something lighter than air and use that to float? The concept isn't unprecedented. Airships, blimps, and zeppelins all rely on lighter-than-air gases to achieve flight. The most effective gas for this is hydrogen. At standard temperature and pressure, hydrogen has a density of just 0.09 kilograms per cubic meter, over 14 times lighter than air. It's even lighter than helium. In theory, a long-bodied dragon with internal hydrogen-filled sacs could achieve neutral or near-neutral buoyancy in the air, just like a fish in water. But how would a dragon produce this hydrogen? Nature has an answer: microbes. Certain bacteria, like Clostridium and Enterobacter species, naturally produce hydrogen gas as a byproduct of fermenting sugars. They possess genes that produce hydrogenases, a class of enzymes that can pull hydrogen from other molecules. Naturally, there's more to it than that, but that is the basic principle. If dragons evolved or were engineered with genes from these microbes, they could metabolize sugars from their diet into hydrogen gas. Alternatively, they could grow these hydrogen-producing bacteria inside their gas sacs or swim bladders, feeding them sugars to generate lift. Either method would allow the dragon to control its internal buoyancy, rising or descending at will, just like a dirigible. And if you've seen my previous video on fire breathing, you know hydrogen also makes an ideal fuel source. A dragon could use its internal hydrogen gas not only to fly, but to breathe fire, giving rise to the iconic image of a flaming serpent streaking across the sky. Although it's worth noting that serpentine dragons are rarely depicted as fire-breathing. Challenges: the volume of hydrogen required to allow them to be buoyant in air would be very high. You see, an object floats because of something known as the buoyant force. The buoyant force depends on the density of the substance that is being floated in. Thanks to Archimedes, we know a rule of thumb when determining the buoyant force is to look at the difference in density between the substance, hydrogen in this case, and the air. The net lift would be the density of the air minus the density of the hydrogen gas. This gives us 1.29 minus 0.09. This gives us roughly 1.2 kilograms per cubic meter. This means that you need 1 cubic meter of hydrogen to lift 1.2 kilograms of mass. Say you have a dragon that's just 300 kilograms. Fairly modest by dragon standards. That gives us 300 kilograms multiplied by 1.2 kilograms per cubic meter. That gives us a value of 250 cubic meters. That's about the size of a 4-roomed house, or 7.5 shipping containers worth of volume. This means that any dragon would be huge just to hold a relatively small mass. Any flying serpentine dragon would be mostly gas. The best environment for such beings would be planets or moons with a thick atmosphere, like the planet Venus, though that presents its own problems. Perhaps I can speculate on that some other time. Hydrogen is also extremely explosive. Even a slight flame could cause the dragon to burn up. Not very good if we want it to be fire-breathing. Conclusion. Though challenging, the idea of a flying, wingless dragon is not as far-fetched as it seems. With a series of hydrogen-filled bladders and the microbial machinery to generate the gas from its food, a serpentine dragon could literally swim through the air. It would be a living airship, a bioblimp with fangs and fire. While the genetic engineering hurdles would be immense, the basic principle already exists in the world. All that remains is to bring them together. But what do you think? Could such a being actually exist? Or should we relegate this to the pages of myth and fantasy? Computer, end file. What did you think of our analysis? Are there any powers, characters, or factions that you would like us to examine? Let us know in the comments below. And to remain updated on the capabilities of your allies and foes, like and subscribe to the Grand Evolutionary.